let's get after some continuity. If you're in the Stewart text, this is 2.5. Um, Continuity is a couple of definitions we're going to discuss that are calculus based, but I'd say the vast majority of this section is just algebra. Do you know what domain means? Do you know how to look at a graph? Do you know how to graph? Sadly, for most of us, like I know myself in the Calc 1 class, no. The answer was freaking no. I could do algebra. I could move stuff around. That's where, as a student, I was really good. I could solve for x. I was pretty good at that shit. Other than that, I was lacking knowledge. Maybe you're in the same boat. So we're calling this calculus with a big old like quotes around it. And there are a couple pieces that are calculus, but for the majority, this section is straight algebra. Let's jump in. Here's calculus. Here's our calculus. So it's saying a function f is continuous at a number a if the limit as x tends towards a of that function is equal to the functioning value at that value a. Whoa, lots of fancy words. It's just saying like, hey, let's take a function that's continuous. Like, how about a line? 7x plus 1. There's a function. And now let's put a limit around it. And let's make that thing go to 2. So where's the limit as x goes to 2 of 7x plus 1? So 7 times 2 is 14. 14 plus 1 is 15, right? If you can just plug the frickin' number in and it's equal, it's the same frickin' thing. It's continuous. It has to be continuous. 7x plus 1 is a line. It's continuous everywhere. There can't be an issue. Because if we say f of x is equal to 7x plus 1, and I ask you, go find f of 2. What's that frickin' answer? Well, that's 7 times something plus 1, and that something was 2. It's the same way we solve this shit. So f of 2 is equal to the limit as x tends towards 2 of 7x plus 1. It's the same damn thing. That means it's continuous. Now let's look at a graphical example. Let's find out where is, let's call this f. F discontinuous. Now this is not the graph of 7x plus 1. I hope you know that, right? Yeah, okay, never mind. Moving on. So where is f discontinuous? No, stop. No need for calculus here. We'll jump back in a second. Continuous means you can take, watch, I'm going to show you continuous. From one side to the other. I never picked up my pen, so that shit's continuous. Now let's give you the example. What's not continuous? Okay, we're done. Moving on. So where is this thing discontinuous? Give me some, and I'm asking where. That's an address. That's an x value. I think at x equals 1, at x equals 3, and at x equals 5. Yeah? Whew, that was tough. I wonder if my algebra students could do that. Yep, yeah, they could. Yeah, they could. So don't make this harder than it really is. But now where you're above, where you're learning and such, we need to take you above where a normal algebra class is. Now let's go look at this. Well, let's say some heights. Like I'm just going to add some shit in. I'm going to call this 1. I'm going to call this one 2. We're going to call this one 3. All right. So we go into it and let's say, well, what's the limit as x goes to 1 of f? Well, that's equal to 1. But you know what f of 1 is? Where's 1? Where's 1? Where's 1? Oh, there's nothing there. Oh, that doesn't exist. Oh, look, so they're not the same thing. It's discontinuous there. Okay. Now let's move on to 3. So we have that the limit as x tends towards 3 of f of x. Well, that doesn't exist, right? That just doesn't even frickin' exist. So if the limit doesn't exist, I'm not even going to look at anything else. What am I going to match does not exist with? 12? No. It's freaking discontinuous. So if you find out the limit does not exist at that number, well, shit, it's not continuous. And now we go to our last one, and we're like, oh, bro, what's up? What's up? We're going to take our limit. Oops, come on, don't scroll up. All right, our limit as x is tending towards 5 of our f of x. And that's equal to, approximately, those heights aren't exactly right, is equal to 1. Cool. Now what is f of 5? Let's plug it in. We're like, Oh, that's that one that's up there near that 3. That equals 3. And does 1 equal 3? Absolutely freaking not. So it's not continuous there. There are the discontinuities at 1, 3, and 5. You could just look at a graph and tell me where it's discontinuous. But that is our definition. If the limit at that number doesn't equal the functional value at that number, it's not continuous. But if it is continuous. So let's do some algebra. Let's get into it. Let's get away from this, all that. Let's just, where are the discontinuities? Problem 1. Where are the discontinuities? Anybody? Anybody? Where are we at? I know, because in the class, usually people stare at me and they just go like, is there a value we're not allowed to divide by? I think that's 0, right? So this is all we're going to do. X can't freaking equal 2. It's discontinuous there. That's where the discontinuities are. Yeah, it's not continuous. There's got to be some sort of freaking asymptote or a hole or removable discontinuity. Because we could take this problem and you might be looking at it and going, but wait, I can do this. And I remember getting confused on this shit too. And you're like, wait, there's no problem. It just goes away. Yeah, but at the beginning, you still can't divide by 0. You plug 2 into the beginning, you're going to create a 0. That is a removable discontinuity or a hole. This graph, it just looks like this. Except at 2, there's a big old frickin' hole there. Moving on. This is algebra. This has nothing to do with calculus. We're just doing algebra. Okay. Now, where is this one discontinuous? Oh, it's a piecewise function. So it's saying everywhere x doesn't equal 1, everywhere, so that's everywhere except for that one point. Our function is this. Sorry about the dog there. It will make noise. So if everywhere it's not equal to 1, we got that function, and then when it does equal 1, oh, it equals 1. Well, if we could graph this would be real freaking simple. We're like x minus 1 all squared. Oh, there must be some sort of asymptote right there at 1. So it must look like this. And everything's positive too. It's just that parent function that I told you about back at the beginning that we have to know. There's our 1 over x minus 1 squared. So it's saying, but oh, when it's at 1, when x equals 1, the y value is 1. So we must be right here. Does that look continuous to you? Nah, I don't think x can equal 1. X equals 1 makes our thing discontinuous. Right, that x equals 1. It's not continuous. Cool. Moving to the next. What about this one? What about this one? Uh-oh, another piecewise. You must love the piecewise function. So we say everywhere it's not 2, we get this function, x squared minus 5x plus 6, all over x minus 2. And wherever, when x is equal to 2, we're going to get, so our y value is 1, negative 1. Don't say that. H of x is equal to this. Our x squared minus 5x plus 6 over x minus 2. So we want to figure out, didn't we figure this out? Yeah, we did. We did this. And we can mess with it knowing that 2 is an issue, but we're not going to mess with it. 2's handled somewhere else. So we get rid of it. And we say, all right, this is just equal to x minus 3. Now, what would happen if you plug 2 into this? What would you get? What would you get? What did you get? 2 minus 3. What's that equal? What's that equal? Does that equal negative 1? So if you were to remove the hole, so we're saying that graph again, it came through like this x minus 3. And then we had a hole, and it goes through y equals x minus 3. So that's at 3. That's at negative 3. This is at 2. That's at negative 1. So we're actually just filling the hole right in. Dude, that's algebra. I teach that shit in college algebra. I teach that stuff in intermediate algebra, where something is continuous. Get on it. This is an algebra problem. We need to be solid with this shit, because being weak with this is going to make it to where you're going to struggle. When we get to chapter 4, you're done. So we got to build ourselves up. It's okay to not have all the knowledge. It's not okay to not do anything about it. Well, it's fine if you don't do anything about it, but don't expect to pass. So let's get better with these so we know where things are graphing. Where is something continuous and discontinuous? And in our next video, I'm going to go into the idea of continuous from the right and from the left. It's just weird. We'll just pop it in. You do a couple homework problems and I never test you on it, but I'll get you on those next ones. All right, see you.